Okay, today in regular chemistry, we're continuing on with chapter 10, the mole. And so now we want to talk, we've talked about mass, we've talked about Avogadro's number, the relationship to moles. Now we want to talk about what volume would a gas be. Okay, so the volume of a gas varies with temperature and pressure. So the volumes of gases are usually measured at what we call standard temperature and pressure, or STP. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atm. Now, obviously, gases aren't always at 0 Celsius, and so then you would apply gas laws to it, and that's a future chapter. So the molar volume of a gas measured at STP is 22.4 liters. So it's saying any gas at STP would be occupying 22.4 liters. And in that 22.4 liters, you would find 6.02 times 10 to the 23rd gas particles. Okay, so these are pretty simple. So you determine the determine the volume in liters of 6.0 mole SO2 gas at STP. So 6.0 mole SO2 times in every 1 mole of any gas. In this instance, we know it's SO2. There are 22.4 liters. Okay, your mole SO2 cancels. You're going to multiply across 0.6 times 22.4. 13.44, but we want 2 sig figs because of the 6.0, so we're going to say 13 liters of SO2. Okay. Next one, you have 0.960 moles CH4 times, you want to get rid of mole, it goes on the bottom, 1 mole CH4, 1 mole of any gas. Volume is 22.4 liters. Mole cancels. So you say 0.96 times 22.4, 21.5. That's your 3 sig figs liters CH4 or methane. Okay. Okay, the next one, you want to go from liters to molecules. So I think I'm going to take this one the long way. You can do it a short way also, but we have 67.2 liters SO2. We want to know how many molecules are in it. So we're going to say that we know that there are 22.4 liters of SO2 in 1 mole SO2 times in every 1 mole of anything, there are Avogadro's number. Okay. You could have just put this here, because both of these would equal 1 mole. Your liters cancel, your mole cancels. So we're going to say 67.2 times 6.02 EE23. Divide that by 22.4. And you want 3 sig figs, so that's going to be 1.81 times 10 to the 24th molecules. You should put SO2, but I ran out of room. Okay, the next one, assuming STP, how many moles are found in 1 liter, C2H6, so you just say 1 liter, C2H6, times, you want to put liters on the bottom. We know 1 mole of any gas at STP is 22.4 liters, so 22.4 liters goes on the bottom, so your liters cancel. So you're going to take 1 times 1, divide by 22.4, and we want our answer in 3 sig figs, so you're going to say 0.0446 mole. Or you can put it in scientific notation, second 5, 4.46 times 10 to the minus second. Okay, next one, same thing we've been doing, but now we're going to go to milliliters, and you should know that conversion. So you're going to say 77 grams. Nitrogen dioxide is NO2 times, okay, we want to get rid of grams, so we're going to put it on the bottom. We're going to look up its mass, so 2 oxygens are 32 and 14 for your nitrogen. Oops. 2 oxygens are 32, 14, so that's 46 grams. We don't want mole, we want volume, so we're going to say in 1 mole NO2, there are 22.4 liters, so your grams cancel. mole cancel, but we don't want liters, we want milliliters. We're going to take it one more step. So we're going to say liters, NO2 to milliliters, NO2. And if you recall, 1 liter will have 1,000 milliliters in it. Okay, so we're going to multiply across the top, 77 times 22.4 times 1,000. We're going to divide that by 46. And we want this in 3 sig figs, so I'm going to hit second 5. And I'm going to say 3.75 times 10 to the 4th milliliters. Okay? Okay, last one, 3 liters of CO2 gas. We want to know its mass. 3.00 liters CO2 times, we know there are 22.4 liters CO2 in 1 mole. Liters cancel. We don't want mole, we want mass. So we say in every 1 mole CO2. So once again, if you're looking at mass, you go to the atomic table and you look up its mass. So Cl is 35.5, but we have 2 of them. So that's 71.0 grams. Mole cancels. So we're going to take 3 times 71 divided by 22.4. We want our answer in 3 sig figs, so we're going to say 9.51, excuse me, grams CO2. So 3 liters of CO2 gas will contain 9.51 grams. Okay, so that is it for this section. It was very short, so now you can do your set 2, which is molar volume of gases. Thank you.